Quantum eraser. This is the topic of discussion in today's lecture. Here, actually, the full name is quantum eraser experiment. This is nothing but the modification of double-slit experiment. You know that double-slit experiment, by conducting this experiment, dual nature of particle was discovered. Dual nature means wave-like nature as well as particle-like nature. For electrons, for photons, okay, the experiment was done, and in this experiment there are two slits. And you know that when the experiment is being observed, okay, means when the path of the, say we are talking about photon particle. We are doing our experiment using photon particle, okay. So when we are observing the path followed by the photon particle, in that case, we do not get interference pattern on the screen, which is behind the slits. On that screen, we do not get interference pattern. But during the experiment, if the path followed by the photon particles is not observed, in that case, we get an interference pattern on the screen. And this is known as double-slit experiment, and using this experiment and analyzing the results of the experiment, physicists concluded that particles are having both the natures simultaneously, wave as well as particle. So this was all about the double-slit experiment. And here in this experiment of quantum eraser experiment, here one addition is there. SPDC technique is used for the creation of entangled particles. Here we are talking about photon particles, okay. So SPDC technique is used to create entangled photon particles. And two slits are there, same as the double-slit experiment, two slits are there. So, and photons are sent to the target one by one, okay, not more than one particle or one photon at a time. One by one they are sent. Now, if you observe the path followed by the photon particle, then in that case, you won't get any interference pattern on the screen, which is behind the double slit. Okay, on the screen you won't get interference pattern. Now, since we are using in this experiment, we are using entangled particles, so the photon which is going through the slits is known as signal photon, and the photon which is being detected by a detector means that photon is not going through the slits, okay. So that photon is detected by another detector, and that photon is known as idler photon, okay. So two names are given, two names are assigned to two photons, and these are entangled pair of photons, okay. By using SPDC technique, normally these entangled pairs are created, okay. Anyway, I am not talking about here SPDC procedure. For that purpose, I will make a separate video how SPDC technique is used to create entangled pair of photons. Anyway, so here, so idler photon is there, okay, and signal photon is there. Signal photon is passing through the slits. So if you do not observe the experiment, means if you do not observe the path followed by the signal photon, in that case you would get interference pattern on the screen. And if you observe the path followed by the signal photon, in that case you won't get any interference pattern. Suppose you are not observing the path followed by the signal photon particle, but idler photon is there, that is being detected by other detector kept somewhere, okay, that is being detected. By manipulating that idler photon, we can easily calculate each and everything about the signal photon. That is known to you because those two photons are entangled. Since they are entangled, so knowing the information about one particle, we can easily know the information about the other particle since they are entangled. Okay, so knowing the information about the ideal particle, how the information will be known? Because that is being detected by a detector. Okay, now suppose detection is made for the idler photon and the signal photon passes through hole, means slits. Hole means here slits, okay, passing through slits. But before reaching to the screen, there is some distance, there is some gap in between the slits and the screen on which photons land. Okay, there is a gap. Suppose when the signal photon is in between the slits and the screen, at that time the information about the idler photon is erased somewhere. Then what will happen? That is the question, and experimentally physicists got perplexing result. They have got reappearance of the interference pattern on the screen. Yes, reappearance. Okay, as soon as the information about the idler photon is erased, they are getting wave-like nature of the photon particle on the screen. That is, so the result is quite perplexing. You can easily understand this. And since the information is being erased, so name of the experiment is given as quantum eraser experiment. Okay, that's why this name is given, because information about the idler photon is being erased during the experiment, during the conduction of the experiment. Okay, so what happens here, you know that according to causality principle, cause occurs first and then the effect we can see. Means if you make the sequence, then in the first position there is cause, in the second position there is what? There is effect. But in this experiment, what we are observing, the photons were emitted from the source. Okay, photons were emitted from the source. So if you do not erase, what you are getting? You are not getting interference pattern on the screen. Okay, and when you are erasing, you are getting interference pattern on the screen. Means when not erased, then you are not getting interference pattern. But when erased, you are getting interference pattern. So seemingly, what is the result? Means the apparent result is that effect occurs first and therefore the cause occurs. So this is going against our classical intuition. This is going against our classical, the logic of classical physics. Okay, means this is counterintuitive in nature, this result. So what is the problem? That means we can, here in this experiment, we can change the past. But in actual practice, we cannot change the past. By doing anything, we cannot change our past. But here in this experiment, you can see that future event can change the past event. Actually, we do not know in detail each and everything about the time in case of quantum experiments, means experiments related to quantum mechanics. Means we do not have proper idea about time, we do not have proper idea about space, or we can say that we do not still know each and everything about the universe, and that's why this apparent result we are getting. Our intuition is saying that that is impossible, the result which we are getting in the quantum eraser experiment. Okay, so some problem is there with time, some problem is there with space. Something new happens in the quantum domain, but still that is not explored by the scientists. Yes, physicists are trying to know each and everything about that field. Means I am talking about quantum realm, but still not known. But the result is known. And result is saying that retrocausality is occurring here. Retrocausality means opposite or reverse of causality. Okay, anyway, so this was all about the topic quantum eraser. Actually, the full name of the experiment is quantum eraser experiment, and this is popularly known as only quantum erasure. This topic is popularly known as quantum eraser. Anyway, so this was all about today's topic. So this is the end of this video. Thank you for watching this video.